If, like me, you have no idea what quantum computing is, you might want to stick around. It could save your life. Or the world. Nothing sounds quite as complicated as quantum computing, and luckily today we're joined by Mark Jackson, who is an expert, and he will tell us all about it, because if you have no idea, like myself, it will be helpful. Mark, thank you very much for joining us. It's a real pleasure to have you here.
Yeah, thank you for having me.
So we're going to talk about quantum computing. That tends to boggle people's minds a little bit. How did it start, and what is quantum computing all about?
Sure. So quantum computing was first thought of about 40 years ago by a physicist named Richard Feynman. And what he realized was that there were certain hard problems that could never be solved by a normal digital computer. And an example of this is in chemistry. So when you try to analyze the properties of a molecule, as the molecule gets bigger, the equations become vastly more in number and much more complicated. And so what he realized was that for these types of quantum problems, we would need a quantum computer. And how it works is this. A normal computer works with bits, which are just ones and zeros, whereas a quantum computer works with quantum bits, or qubits. And a qubit can be a 1 and a 0 at the same time. And so it's sort of like you can do two calculations at once. So just as one qubit can do two calculations at once, 2 qubits could do 4 calculations at once, and 3 qubits could do 8 calculations at once. And there are certain types of problems that can take advantage of this, of doing many calculations at once. It's not every problem, but there are some. And to illustrate just how powerful this could be, if you had a quantum computer with 300 qubits, that actually corresponds to the number of calculations that would be possible by everything in the universe being turned into a normal computer. So this means that even in principle, you could never build a computer more powerful than this. And so again, this is a quantum computer with just 300 qubits. People are talking about building quantum computers with thousands or even tens of thousands of qubits.
Mm-hmm. With that in mind, how will that sort of change things moving forward when this is implemented?
So there probably won't be an industry or a sector which won't be affected by quantum computing. So in the financial industry, for example, the two areas of quantum computing which will probably be most important are encryption and security and machine learning. And to explain why encryption and security is important, one thing that we know that quantum computers are very good at is cracking most of online security as it is today. So most of online security today is based on a particular mathematical problem which normal computers are very bad at solving. Since quantum computers are very good at it, it means that in principle they could hack anything that's encrypted using today's technology. They wouldn't be able to do it today. It will probably be in about 5 to 10 years when quantum computers become more important, but at some point this will happen. Fortunately, we've already begun to develop protections against that. And then in the area of machine learning, quantum machine learning is actually a completely new type of technology. So it's actually mathematically much more sophisticated than normal machine learning. And the hope is that we would be able to solve problems that never could have been approached using normal machine learning.
Mm-hmm. You mentioned finance briefly there, but what industries will be most interested in sort of applying this technology?
So I think one area will be chemistry, for example. And as I mentioned, this is sort of the original reason that quantum computers were invented. I think another will be scientific simulations, because a lot of simulations depend on quantum physics. And by having a quantum computer, we would actually be able to do this. I think communication will be much more secure. So as I mentioned, sort of the threat of hacking by quantum computers have actually led to a lot of new types of technologies which are unhackable.
You travel around, do a lot of lectures. Education is very important to you, I'm guessing. What sort of lessons can Switzerland import from Berkeley in terms of education in this area?
Because quantum computing and the related technologies will have such an impact on so many sectors, I think it's really essential that everyone from CEOs to students understand what this is. So executives should learn about this to understand how their existing company will be affected by this. But I think younger people, like students, should learn how to program and how to understand the technology at a much deeper level to take advantage of this.
Mm-hmm. That's an interesting point, just to finish up on that idea of educating younger people and learning to program. Have you seen a spike in that, or is it going the other way?
Yes, no, there's actually, it's actually difficult to get qualified talent in this area because quantum information science as the formal term is a relatively new subject, and so there are not many young people with degrees in this. It's usually people with backgrounds in physics, such as myself, but who have had to sort of learn about quantum computing after the fact. And so I'm happy to see a lot of young people starting to get into this. It really is a new field, only about 2 years old commercially.
And just finally, a few words. Are you fairly optimistic looking ahead?
Yes, I'm very optimistic. Again, even though quantum computing was thought of about 40 years ago, it really only started to take off commercially about 5 years ago, and the past 2 years have really been explosive. It's estimated that about $1 billion a week is spent on quantum computing in the Western Hemisphere. So I think this is a very promising sector. I think there's a lot of excitement, both from the commercial and government perspectives.